Hey, welcome back to Math with Patrick. Today is February 28th. We have problem number 59 from this Daily Epsilon calendar, and we're going to solve it together. All right. So it looks like we have just like an arithmetic problem where we do some math here and show that this is just the number 28 wearing a funny hat. Okay, let's see. So with a fraction, usually it's best to solve what you have on the top, solve what you have on the bottom, and then do the division afterwards. But I'm noticing that we're going to get some obnoxiously large numbers. We have essentially 9 to the power of 2025, which happens to be this year, which I think is kind of funny. And that's going to be a massive number. It's like kind of close to 10 to the power of 2025. And this is going to have over 2,000 digits. So there's no way that I'll actually be able to compute this number. Hopefully I'll find some nice cancellations with the bottom instead. So, well, I have 9 and a third times itself 2,025 times. That's kind of ridiculous. And then I have 3 times itself 2,023 times. And then 3 and 1/9 times itself 2,024 times. And somehow, all of this simplifies to 28. I'm noticing like a lot of 3s here, and so maybe there's going to be like, oh, wait a sec. You know what? Hold on. So looking at the bottom here, I'm going to factor this right one a little bit. Basically, I want to find a common exponent between the numbers in my denominator. So I'll keep my numerator the same. That's still going to be 9 and a third to the power of 2025. But then on the bottom, I'm going to take out an extra 3 and 1/9. And then, so I'm going to have 3 multiplied to itself over and over and over again, 2,023 times. And I'm going to have 3 and 1/9 multiplied to itself over and over and over again, 2,023 times. And you can do multiplication in really any order you want. I was kind of talking about this in yesterday's video, actually. And this just tells me I could combine my 3 times 3 and 1/9 before I hit it with the exponent of 2023. Now, it doesn't really look like I did all too much. My goal was to compare these two numbers, and I think, yeah, okay, they're going to be the same one. 3 times 3 and 1/9 basically just says take 3 and 1/9 and add it to itself 3 times over. And it becomes pretty clear that you get 9, and then 3/9 is the same thing as 1/3. Maybe I can prove that to you with a little picture model. If I shade in 3 out of 9 squares, that's the same thing as doing one of the 3 columns. So rewriting it another time, I have 9 and a third multiplied to itself 2,025 times, divided by 3 and 1/9. And then here's another 9 and 1/3. This one is multiplied to itself only 2,023 times. Saying only is kind of silly because that is still an obnoxiously large amount of times, but it is less than this amount in the numerator. And when we're doing fractions like this, if you have some repeated factors in a fraction, say we have something like 10 divided by 15, if you have common factors, you can cancel them. Because if you multiply by 5 and then divide by 5, that's not really changing your value. So like 10 over 15 is just going to be the same thing as 2/3, and it's a bit more simple that way. And here, I have a whole bunch of 9 and 1/3 on top and a whole bunch on the bottom. And you can imagine that I'm just multiplying 9 and 1/3 times 9 and 1/3 times 9 and 1/3 so many times over. But I'm going to have 2 extra on the top because I have, well, 2025 on top and only 2023 on bottom. So that leaves me with 9 and 1/3 times 9 and 1/3 on top, and then just the 3 and 1/9 on bottom. So I've kind of dealt with like the really, really large exponents. I'm no longer working with obnoxiously large numbers because fortunately I found a good cancellation. Now it's just time to, well, multiply, divide, and apparently this is going to be 28. So let's show why. Um, Usually I like doing multiplication and division with improper fractions rather than mixed numbers. So 9 is the same thing as 81. I was going to say 81 ninths, which is true, but actually I'd rather have a denominator of 3 instead. So that's going to be 27 thirds. And so I have 27 thirds and one more third. And so overall, both of my numbers in my numerator are going to be 28 thirds. So 28 thirds times 28 thirds divided by, and then my denominator, I think I still, I need that denominator of 9 down here. 3 is going to be the same thing as 27 ninths, because, well, 27 divided by 9 is 3. And so one more ninth gives me 28 ninths. And when you're doing this kind of fraction multiplication, you can just kind of multiply across the top and across the bottom. And knowing that the answer today is going to be 28, I'm actually going to do a little bit of an algebra strategy here where I'm just not going to care about what 28 times 28 is just yet, because I don't think I need to know that number. 3 times 3 on the bottom is 9. And then when you divide fractions, sometimes it's an easier strategy to keep the top or the first fraction the same. And then instead of division, do some multiplication, as long as you flip the last fraction or find its reciprocal. Now I can find some nice easy cancellations. Kind of like I said before, you can cross off common factors on the top and bottom. And here's where not multiplying out that 28 is really helpful, because I can just cancel this 28 with one of them here. And all that's left is just the number 28. That's today's date, the last day in February. And we just figured out that this massive number this massive number divided by this other massive number turns out to be just the number 28. Today's date, isn't that just great? Okay, rhymes aside, we're all done. Thanks for coming along, and I'll see you in March. All right, bye.